Hey, good day, and welcome to FiredHeaterPro. Today we're going to be talking about the process stream module, so let's dive right in. Here on the main screen, we go ahead and open up that collapsed view for process streams. What you get is a grid. FiredHeaterPro operates off of a grid. You've got your properties laid out by temperature, and we've got vapor fraction, your densities, viscosities, specific heats, thermal conductivities, and the enthalpy of the mixture. Up here on the tabs, you've got pressures. So we've got the same temperatures at various pressures. And what that enables FiredHeaterPro to do is to do a double interpolation and get those fluid properties wherever your simulation happens to be. If you go outside of these pressures or outside of your temperature range, then FiredHeaterPro will extrapolate, but I highly recommend against that. You want to go ahead and bound your fluid. I like to do it 50 pounds below, 50 pounds above, 100 degrees below, and 100 degrees above if I can, just to catch all cases. You can create a new stream if you want and hand jam it. You can see I've got my 14 pounds right here. I can add another one if you want. You can absolutely hand jam these. You just get however many temperatures you want. And you can just kind of go for it. The only problem with this approach is that it is time intensive. You know, it's gonna take you just a long time to do all these, and especially if you've got finer gradations of temperature than I have here. I have a temperature point every 100 degrees, and if you've got it every 20 degrees and you've got 20 or 30 points, then hand jamming this information, it's going to take a really long time. So if I were you, I wouldn't do that. What I would do instead, I'll just go ahead and delete this here. I would import from Excel, okay? We're going to import from Excel, and I'll kind of show you how that works. Okay, we're going to get our import process data. And I'm going to import a new crude stream. So there's my file. I drag it over. I drop it in. And look at that. It imports the whole file for me. Too easy. In order for this to work, you've got to have your data set up in just the right way. If you want to see a template for it, click Import from Excel again, and right here, you've got a sample file you can download. This is a sample file. It happens to be for Therminal 55, but that doesn't really matter. That's not the point. The point is that you have a file and you can see exactly how it needs to be set up, and you can set it up that way. Here we have an example of the format that FiredHeaterPro expects. I applied a bit of formatting to the file so you can see it better, but that's not going to be there in the sample file, and it doesn't need to be there in the file you upload. Right here we've got our properties, and the first one is just it says property, and out to your right here you've just got sequential points going from 0 out to whatever you have. I've used files that have 60 properties. It doesn't matter. We have temperature in degrees Fahrenheit. You've got vapor fraction, liquid density in pound mass per cubic foot, vapor density, liquid viscosity. That's going to be your dynamic viscosity in centipoise. Same with the vapor. Your specific heats and thermal conductivities are in the common US customary unit. A quick note here on mixture enthalpy. This is really a relative number. So in this case, the process engineer who made this data set, I'm not sure exactly where they put the datum line, but it's well above where we are now. But that doesn't matter because what FiredHeaterPro does is it takes 2 points and it calculates the enthalpy difference. So that's what's key here. Another key thing is your tabs down here. Your tabs are going to be in PSIA, and you put however many tabs that you want to interpolate across. You need to have the same number of temperature points per tab. And they just need to be formatted just like that. No big secret to it. Another thing about cleaning up your data. Right here I have an example of a naphtha stream that I had to recently use. Here in green, I've highlighted vapor fraction. This is the only row in your data set that should include zeros. Any other row that includes zeros is wrong. In this case, the process software, it kicks out a zero if a value doesn't exist. So for example, we've got a vapor fraction here of 0.06 at 0.3 going to 0 and 0.2. So for 0.2 and below, all the vapor attributes are 0. The attribute doesn't exist. The process software is giving a null value. FiredHeaterPro works on interpolation, so having these 0 values could potentially give erroneous results. To get an idea of these erroneous results, take a look over here at liquid density at 0.8. It's 0, it's null because there is no liquid. The vapor fraction is 1. Unfortunately, there is this space between 0.87 and 1 where you're going to have some liquid, and it shouldn't be interpolating from 0 to 43 pounds per cubic foot. That's going to end up with a much lower liquid density than is realistic. So there's two solutions here. The first solution is that you can have your process software put the vapor fraction at 0.99. And what that will do is it won't give FiredHeaterPro a chance to interpolate a wrong value. Likewise, at the lower end of vapor fraction, you would want to have that low number at 0.01. Alternatively, if you're okay with a small amount of error, you can just extend these numbers out so that the last number before the 0 is what you use. If you look at the rate of change of these variables, it's usually not very much. Also, between the last point and the last point where you have liquid and the point where it's all vapor, it's not very many percentage points there of liquid you can possibly have. So while this technique introduces a small amount of error in the simulation, some will find it acceptable and some will not. If you find that unacceptable, then set your bounds to 0.01 and 0.99. That way you never have a situation where you're extrapolating into this unknown incorrect territory. I'd like to go over a couple of more features of FiredHeaterPro while we're at it. In addition to importing from Excel, you can export to Excel. That's a good feature for if you get some data input and you want to save it, or you've imported some data from a different computer and you want to save it on your current computer so that you have it handy just in case it gets messed up. So you can always export to Excel. We also have this add from library feature. We're going to be adding more and more fluids as we go along. Right now, what I've got is Thermanol 55, made by Eastman Chemical. It's a pretty common heating oil. So I can add that, and I've got it just like that. Very simple. The final thing I'd like to show is that we have a little local calculator down here. So what I can do is I can input, say, 59 pounds and 470 degrees. and I can get calculated properties at any given pressure and temperature. Of course, FiredHeaterPro does these calculations automatically for wherever the fluid happens to be in the simulation. But in your case, if you want to run this calculation because you need a particular value from your data set, you can do that. All right, that's all for now. And as always, give me a shout, give me an email, info@firedheater.pro if you have any further questions.